Freeman, and I am playing the role of the administrator. This is a 8th grade math team. We have Michael Freeman, who is the department head, and then Bethany Brown and Chris Levins. Make sure you talk loud enough for the camera to pick it up. All right, Mr. Freeman, this is our first PLC back. We're planning for the start of the year. What do you have for us?
I pulled up the scoping sequence for 8th grade math just because I haven't taught 8th grade math in a couple years, and Chris is kind of taking over the role as the 8th grade math department head, if you will. And so just to make sure that the scoping sequence we're using, and then they got really good results last year, so kind of just seeing like what have they changed since the last time I've talked about it, and to see like this is the same scoping sequence we follow, and how they might have adjusted some things. So they've had some really good results the past couple years.
To piggyback off of that, Coach Levins, I was at the board meeting last week, and they gave you a personal shout out when they were presenting not only STAR data, but map growth data, because y'all's group was one of the only ones that showed growth consistently. So
Awesome.
y'all were called out intentionally.
Well, that makes me feel really good. That's good. So I think we got to teach a few years ago together, and nothing really as far as the TEKS go has changed. What I've started doing more is bringing back information that has been taught. Instead of just teaching and letting it go. Like doing algebraic equations at the beginning, is something that I feel is important because, it's one of the topics they need for high school. So if we teach at the beginning, we can review it and review it and review it and review it throughout the whole year. And that way they go into high school with a really good grasp of that concept. So.
And I feel like in 8th grade math, like almost everything's an equation, whether it's simple and compound interest or y equals mx plus b is an equation. Like they can solve an equation, like equations are out throughout the entire year.
Yeah.
Like Pythagorean theorem's an equation, or I think everything almost is an equation for the geometry stuff. So really they had a firm grasp in that, and really that's going to lead them to be successful in everything else.
So when y'all are talking about starting with equations, are you talking about solving equations or graphing equations?
Solving, right?
Solving
And writing.
Yeah.
They have to be able to
write a word problem.
Yeah, they have to be able to solve two equations with variables on both sides. They have to be able to write a word problem.
And model an
And model.
equation. Yeah.
They have to be able to like reading the problem and writing the equation, or giving an equation, match a word problem to it. So all the different ways.
So obviously that's a standard that y'all have done really well on in the past, but looking at the 7th grade data from last year, so the students y'all are getting, they did not do very well on TEKS 7.3b, which is a readiness standard, and it focuses on solving problems using addition, subtraction, multiplication, and division of rational numbers, which obviously is going to tie into that solving equations TEKS that you're looking at. They only scored about 40% on those types of questions. So is there anything y'all think you need to do differently, knowing that they're coming to you with those weak skills?
Well, one thing that's different between 7th and 8th grade is they have a calculator, right? So
Okay.
I think the calculator fills a lot of those gaps. But also, we've started using this scoreboard method to combine like terms, to add integers, and that has been a huge help for the kids to see that. So I'm going to try that and see how that goes.
I forgot they also have to do inequalities in this first unit as well. That's one of the TEKS. And like Chris said, so last year, did y'all start with like 1 step and 2 step, or did you go straight into variables on both sides?
I went straight into variables on both sides.
Yeah.
I don't know, I felt like that, actually, I don't know, I think I start off with like a basic equation, 1 step, you know what I mean? So it'll make sense to them. Like, I think I go with like 1 plus 2 equals 3. You know what I mean? Which is simple, everyone knows that. And so then I'll move that positive 2 to the other side, of the equal sign and be like, okay, does 1 equal 3 plus 2? You know, they're like, no, it doesn't. So we talk about how whenever you manipulate an equation, how you have inverse operation, you know, and then, you know, pretty quickly after that is when we go into solving algebraic equations with variables on both sides. So I don't spend a long time on it, but having some knowledge of how to manipulate an equation is beneficial, I think.
I think it's hard for them to understand x. It's like x plus 7 equals, you know, like to get them to understand that x is just an unknown. We're like solving a mystery. Like whatever, we don't know what it is, but we're gonna figure it out. And then also getting them to be able to then use their answer, go back and check it. Just if you have the calculator, like we got a calculator now, like you should be able to check this answer really simply to make sure they're equal. So I feel like giving them the tools to be successful and showing them how to use the tools they have to check their work, like there's no reason we should miss these problems.
So after solving equations, where do y'all kind of move in your curriculum?
Well, after we solve them, then we go and talk about the different types of word problems. Can they write a word problem, or can they read a word problem? So then the inequalities is really like they don't really have to solve them; they just have to be able to write them. So that's where that comes into hand. And then Chris has this cool thing where he talks about like if Patrick Mahomes is greater than I don't know Alex Rodriguez. And they talk about the symbols and how like whichever one's greater gets 2 dots, whichever one's smaller gets 1 dot. They gotta make the symbol. So they do it with like pictures first, and then get them to understand the symbols, and then they can use it to solve the inequalities, and then like it's really helped them. It's really because the kids like it because it's always like popular people that they know, and so they laugh about it and stuff. But also they're learning, and it helps them like understand greater than versus less than. Because I mean, a bunch of them like think, oh, alligators and all that stuff. They mess it up. You show bigger one gets 2 dots, smaller one gets 1 dot. Super simple. So
Yeah, I love that. I love that.
it's great.
That's so great.
And then like getting to understand the different types of vocabulary, which is rarely will it say this one is less than or this one is greater than. Like, understand that vocabulary. Well, if it says more than, it has to be more than. Like, does that mean equal to or not equal to? And so going over that vocabulary. There's a lot of vocabulary in this first unit that most of them either haven't seen before or really didn't grasp very well.
So in 8th grade math, do they have to do anything with inequalities on a number line?
No.
No. Okay, because that is something that they are weak in coming from 7th grade. So TEAC 7.10b, they only got 17.75% across the board. And that's representing solutions for 1 variable 2-step equations and inequalities on number lines. So there's a lot to unpack in that TEAC. It could be, do they not understand the inequalities? Do they not understand the number lines? Or are they struggling with those solving equations? But all of those skills, it sounds like, are going to be important into 8th grade. So you need to anticipate that they are coming to you with very little background knowledge because they're weak in it in that 7th grade department. So does anybody have any ideas on how you could be intentional about anticipating those misconceptions they might already have?
I think a lot of students in 8th grade have trouble with number line, right? And I see that whenever we look at a coordinate plane, right? So we do a lot with the coordinate plane about them filling out their own coordinate plane, right? And the x-axis and the y-axis, because they don't know, some of them, where the positive numbers go, where the negative numbers go, right? So, and then having them look at a number line, you know, and they have the greater than and less than symbols on it, right? And showing them like, hey, see this on the left side of the number line? That's a less than symbol because it's over there with all the, you know, the negative numbers, and the one over here is a greater than symbol, you know, just giving them knowledge of that number line helps them sometimes, you know. We put numbers in order from least to greatest too, which helps them with the number line. But I think that's what you're asking. But
just ways that we can support them in gaining that knowledge, because we
Yeah.
don't want them getting to high school with a gap if that doesn't necessarily relate.
See, and we'll have transformational geometry where they have to talk about how a shape moved about the x-axis or y-axis, and so we get into that a lot during that unit. So that's pretty similar to that part, I think. But maybe slope and y-intercept too, where they have to graph a line on the coordinate plain, you know?
Because I make my kids do that. If it says X is greater than 2, I make them circle the greater than, and then circle it's over here, so the arrow points that way. Like I make them like circle it. Like, hey, the symbol matches the arrow. They're like, what? And they act like I'm like, dude, how's no one told you this before?
Yeah.
Like, so maybe that's something we need to talk about with 7th grade teachers and PLC. Like, when they're graphing stuff on underline, like, make them circle the sign, make them circle the arrow.
And like you said earlier, you know, if there's 2 dots next to something, that means they're greater. If there's 1 dot next to something, that means they're less. So just getting vertically aligned 7th grade and 6th grade, I think will be a huge help about that.
Like, I wonder if like in 7th grade, like, do they have I'm not sure what you know, like, their graphing, is it always the variable on the left? Is it always X is greater than 2, or do they ever like switch it up and do like 3 is less than X?
That's a really good question. To my knowledge, it's always the variable on the left, but I think it starts switching in 7th grade, so it might be we need to look at those representations. But I'll make a note to pull those previous tests and just see how it's being assessed.
I think some kids saw it with the X's there, and they just switch the things without switching the signs. I think it's important for them to practice, like, hey, 7 is less than 10. If I switch it, is it still true? Like, no, yeah, if I flip the numbers, I gotta flip the sign too.
Yeah.
So maybe in the field, the variable on the left, and the sign always matches.
Yeah, you know what, I'm thinking back to the inequalities that we have to teach, and, you know, the answer choice isn't always written how the student thinks it's gonna be written. Sometimes it's backwards,
Yeah.
right? So having that conversation, like, okay, it's okay if we flip everything, but we have to flip the sign too.
Yeah.
I don't know, that'll be something that kind of ties into that TEAC as well. But,
So, looking at those new item types that were introduced a couple years ago, something that comes to my mind, you're talking about the representation of how an answer could be. Have y'all ever thought about using Eduphoria or something like that, where you could have a select all that apply and say which ones all represent this answer? And so you could give them the answer X is greater than 3 or whatever it is you're doing, and different representations of it, whether it be on a number line or you're reversing it or anything else, and just considering like which all of these are equivalent. Would that be something?
I think it'd be great because it's like multiple representations, right?
Yeah, it's a
They,
big
they
thing.
see it, that's a big 8th grade thing, is like multiple representations. Can you graph it? Can you put it on a table? Can you make an equation? Like,
Do a word problem.
Word problem.
It's all the same stuff. That's where kids struggle a lot. They don't understand that equations, graphs, tables, it's all the same information. Like, it's all just different ways of showing it. Like a visual representation or a oral representation.
I think that like making like some warm-ups where, you know, they could come in and they could get an equation, and then maybe they graph it the first day, and then maybe that same warm-up, okay, then they gotta graph it and write a word problem to go along with it. But like, I think that'd be a good thing to do to address that gap.
And Ms. Brown, I know you're new to our campus and to the math team.
Yes.
You haven't taught 8th grade math before,
I have
correct?
not yet.
So, if you have any questions on anything, something doesn't make sense, don't be afraid to ask. These two have been teaching it for a really long time.
Appreciate
So,
it, yes. Learning the curriculum, getting ready for the year, appreciate it.
got 2 good people on your team.
I do.
Well, what I really like about what you've been doing is like all the questions you've been asking, like, that to me is like one of the biggest things, you know, it shows that you care and like we wanna help you and you're willing to get help, like, I love that about it.
Yes, my old school collaboration was the #1 thing in these PLC meetings, so thank you for inviting me into them.
So before we keep going in the scope and sequence, because I know that we do want to change a couple of things, I pulled the data and I just want to talk about a couple of the things. So first, starting off with those celebrations, 8th grade had the highest approaches percentage of any on-level content, which was awesome. Second positive is the TEACs that focus on identifying functions and graphing were exceptional. We were in the 80% passing range on all of those. There were only a handful where the data indicated some gaps that we need to address in our scope and sequence. So it's not necessarily a bad thing, it's just an opportunity for us to grow instead of focusing on that negative. So I am gonna go over a couple of those with you So I'm gonna talk about the lowest 5, and we'll discuss how they're related, how we might adjust our planning for this year moving forward. Is that okay with everyone?
Yeah.
Okay, so the first one is 8-6C. We only had 13% of our students be successful on that TEK, and that's using models and diagrams to explain the Pythagorean theorem. Related to that, 8.7D, we were only at 26%, and that's distance between points using Pythagorean theorem. So since those two are related, let's talk about them. How did y'all approach Pythagorean theorem last year, Coach Levins?
Well, first of all, I show them a picture of a right triangle, like a diagram that is probably not the diagram that they saw, right? So I give them a diagram, a triangle with a square coming off of each side, you know? And so I just ask them what they notice about it, and eventually someone says, oh, look, the small square plus the medium square equals the large square, right? And so from there, then we go into like, what is this formula? A squared plus B squared equals C squared, what does that actually mean? And they figure out, oh, it's the small plus the medium equals the large. And so we look at it like that at the beginning, and then we can do the inverse of that. And I don't know, I'm sure, I've not looked at that question that you're
Mr.
talking
Freeman,
about.
could you go to Lead Forward and see if they've released those items in there, and if not, we can pull up those questions in Cambium. So let me know when you're ready for those TEKs. Or you don't know if I want to.
So,
Is 2025 in there yet?
I don't know, it's on the next.
Oh, okay. So it's 6C and 7D.
But as far as like graphing, like the distance between the 2 points,
No, it's not.
Okay, so can you go to your results in Cambium and we'll see those exact questions. That way we can break them down and talk about them.
That no need for you. That's it, is it, that's.
I thought you had access to all math students. If not, it's okay, and we can pull up the Lead Forward.
I'll see if I can get on Lead Forward right now.
It only had the 2024.
Oh,
Yeah,
okay.
they haven't updated the 25 yet.
But yeah, I'm sure that it was probably a square with a bunch of triangles coming off the square, like the classic
Mhm.
Pythagorean theorem diagram you think of. And I am guilty, like I did not show them that diagram. Like I
And what
did
about
not.
distance on a coordinate plane between
So
points?
what I think is that happened there is I bet you a ton of kids were like, oh, there's 2 dots, you're right, and I bet you they did slope. I bet you anything, and when they didn't get the exact answer, they're like, oh, guess, you know, because it looks very similar to like find the slope of the line, you know, so I'm sure that's what happened. So just like pushing, like, hey, just because there's 2 dots on a on a coordinate plane doesn't mean it's a slope problem. And just because there's 2 dots on a coordinate plane doesn't mean it's Pythagorean. There could be anything, right? It could ask you anything. Like, is it proportional? Is it a function? Is it slope? Like, what's the slope? What's the binary? So there's many things you could ask about those 2 dots. So
Oh, so you didn't look at the actual, can I see?
Yes, please.
So remember when you're going to look at the actual data, we need to be in CRS, not test authoring.
here we go. I bet you that's what it is right there. I bet you that's that. Which I did not show them even one time.
Alright, so we can look at these teaks right here, and we'll just go. Yeah, here's one option with the measurement. So can you put that one up on the screen for us and we'll talk about it?
Yes.
Okay, so this is one of the questions from last year's test, or this past year's test. And this will be focused on that 8.7D, distance on a coordinate plane using Pythagorean theorem. So, what are the first things that you notice?
What do I notice about this problem?
Or why
Did they
students
miss it?
might not be successful on it?
What I think is if my students weren't successful here, I think it's because they looked at those 2 points and they're like, oh, there's 2 points, I'm gonna find the slope. And so they probably went and found the slope and realized, oh wait, that's a negative slope. None of these answers are negative. So I'm sure they just circled an answer. And then maybe they found the y-intercept and they're like, well, none of those are the y-intercept either, you know? So I don't know, it just, to me, that problem looks a lot like a slope and y-intercept problem, looks a lot like proportionality problem, looks a lot like a function problem. So I think you really, I don't know, you really gotta read the question, you know, so.
So I'm trying to pull up here.
But how I taught that was to start at the first point, and then to rise and run and make a triangle, and then do the problem like that.
I'm gonna assume most people missed it, picked B. Because the legs are 6 and 9. Said, oh, 6 plus 9 is 15. There we go. Whereas,
Maybe, yeah.
even if they didn't know, if they know, oh, it's 6 and 9, the other one's gotta be bigger. It's never just the two numbers
Yeah.
adding. It's
Yeah.
gotta be D without even
Yeah.
having.
Yeah. Yeah. What answer do they pick? Who knows?
I guess I would assume B, but
Okay. Trying to see in here if we could see the breakdown of responses. So this was question 15. So it looks like the majority of our students picked D. Or sorry, D was the correct answer. The majority of our students picked A, 9 units. So what might be causing them to select 9?
I think that if you count diagonally on that line, you're gonna hit 9 quarters. That's what I think. I think that's why they picked 9.
So they're just counting?
It counted.
they just try to
yeah.
go, alright,
Count.
I just did. Yeah, it's not.
Which is not what I taught. However,
It
if
never
you
is,
count
yeah.
diagonally, you're gonna see 9 corners through there, yeah.
And like almost the same amount picked B, which is definitely, oh, 6 plus 9 is 15.
So what might you be able to do differently this year to kind of anticipate that misconception? It's okay if you don't have an answer right now, it's just
Well, I
something to
think
think about.
I think that having them read it and have them, once they figure out it's a Pythagorean theorem problem, like draw a triangle on it, right? And then bigger than that, maybe draw the squares coming off the edges of the triangle, you know? So, I don't know. And then like hammering home, like, look, there can be a lot of questions asked about 2 dots on a coordinate plane. Like, so let's figure out all the questions that can be asked, and let's make sure we read carefully so we don't make that mistake again. I think showing them mistakes the kid made last year is a big benefit to the kids coming up. Like,
Yeah.
look, this is what they missed.
So let's pull up a question. Okay. 27. Okay, so on this question, this is about that using models and diagrams using models and diagrams to explain Pythagorean theorem. And only 13% of our students got this question correct. The majority of them picked D. We had 51% of our kids pick D.
They add them together.
They added the
find
data square root. Yeah. Yep.
Okay, so it seems like, hold on, sorry, I think my laptop timed out. I just want to check it.
Yeah, that looks like my diagram.
Okay, sorry, laptop timed out over there. We're good to go now. Yes, we're still good. So it seems like the reason they're missing both could be connected, right, without taking the square root, or they're just adding two together. So they know to add, they don't know what to do from that. So we need to be thinking about ways we can approach that a little bit differently, knowing that that's what they're struggling with.
51% chose D.
So they knew
they
to add
them
them up.
together.
Yeah.
And they didn't. That's the area. I know when I taught it a couple years ago, like I did not do enough practice with talking about, all right, well, this is the area. What's the side? Or, like I know, like in some of the problems examples we have, where it's like we have an area and a side, and they gotta find the other area. We gotta find the other side. Like I need to do more practice about that.
And you know, the classic question with this diagram has sentences for answers, and it says
Yeah.
the area of square x, or the sum of square x and y is equal to z, right?
Yeah.
So that's what we were practicing.
Yeah, I'd say
X plus
past
y equals z. X plus
3,
y equals
4,
z.
5
And they got
years,
that.
I feel like.
Yeah.
Another reason for the low percentages on those is each of these TEKs was only assessed with one question.
Yeah.
They're supporting, so.
They're supporting.
That's right. It's tough.
Yes. And y'all as a team have kind of nailed the reporting categories. So all of the reporting standards were y'all's highest scored TEKs, which is always what we want to see. That's why y'all have so much success in the amount of kids that are scoring approaches. But if we want to take it to that next level, we're gonna have to focus on some of these supporting standards that, especially the ones that are leading into their high school math courses, because this is a really big focus in geometry.
Yeah.
So another one I want to go to is earlier you were talking about the coordinate plane and how when you get to transformations, y'all focus on that. But one of our lowest ones was comparing and contrasting attributes of shapes and their dilations on the coordinate plane. So we did really good with the other ones, reflections, rotations, translations, but dilations seemed to give us trouble. Only about 19% got those correct. So we're looking at 8.3b, which is, there's one right there, question 13. So if you'll go back and show us question 13. And I know this is y'all's first time looking at these. They were just released a couple of weeks ago. So it's right here. So it's dilated with the center of dilation at the origin. Which statement must be true? This looks like a complicated question. Every answer choice is represented in a different
That's a weird
way. So on this question specifically, 20.34% of our kids got it right. And then they were kind of almost evenly split between A, B, and C. The majority of them picking B.
B.
B, 35% chose B.
I have never seen an answer like this before.
Yeah. That does look different. That looks different
Because
than.
we always do like P comma Q equals 3P comma 3Q. I've
Yeah.
never seen it written like that.
And see, coming from an old geometry teacher perspective, this is how it's represented in high school geometry. So maybe that's a vertical alignment piece that the state is trying to do.
Yeah.
I've never seen
Without
it
letting
like that.
anybody else know, but that is, you would say P prime Q prime is equivalent to 3 times the original, which was
they-
PQ.
I am not surprised to miss this because I've never seen it written like that. I mean, probably a long time ago when I took geometry, but never at an 8th grade level. So I've never practiced it like that. Hey, I'm surprised 20% got it right. And I think they could just eliminate the other ones who are obviously wrong. But
I think that if that would have had like algebraic rules for A, B, C, D, like 1/3 times X, 1/3 times Y, or 3 times X, 3 times Y. I think they would have a chance at that, but
So here's a couple of other things I'm noticing. We know dilation is multiplication, right?
Right.
And A is the only one that uses the word dilate. It has that factor of 3 in there with the 1/3.
Yeah.
So we know they knew it wasn't getting smaller, right? They knew it was getting bigger. They didn't select that one. But by process of elimination, why weren't more of them able to recognize that 3 outside the parentheses is multiplication
Yeah.
in answer choice C.
Yeah.
I think, but it's just one of those things where they've never seen something written like that. Why would I pick something I've never seen before? Whereas B kind of looks like
Like
slope
scale
triangles.
factor.
It kind of looks like when we do slope triangles, kind of. They're like, maybe that's what it is. That's at least looked familiar. So I think that's why that was probably the most chosen answer. 'Cause, I mean, D is, they're obviously not congruent. So I'm glad that not everyone will pick that. But I mean, me just looking at the very beginning, I was like, what are these answer choices? I didn't really like stop and like think about it before I always do
Yeah.
I always do like the original equals the new. I've never even seen it written where it's
Yeah,
P
backwards.
prime Q prime equals 3PQ. It's always
Hey, you know what?
3PQ
That
equals-
goes back to what we were talking about earlier. When you write it in equality, you can write it the other way too. And it's like maybe we got to start hitting that home. Like, okay, it might look like this, but it might be reversed and look the other way too.
And see, I think that's more representative of how we use equations. Like, even if
Yeah.
you're thinking about y equals mx plus b or direct variation that y equals kx, we put the answer on the left, right? And p
Yeah.
prime q prime, that is the result.
That's the-
So they are used to having the result on the left, and on the right hand
Yeah.
side, we're seeing the math that's happening, the transformation that's taking place.
Yeah. See, like I'm with you, Michael. Like, so over the last 15 years, a dilation question
Yeah.
has never had answer choices that look like that. But to your point, it's like should have been able to eliminate some answers, and you know that dilate means multiply. It's pick one that has multiplication in it, right? Which
Yeah, like I said, like for them never to say, hey, they know. Like I said, I've been doing this in my 14th year. I've never seen it written that way.
yeah,
So like I've never practiced that way. So
that gives you something else. So like when we're practicing this year, it's like okay.
like, how else can we write this? Can we flip it? Can we do that? Like all the different ways.
It's tough. That's the hard part. Is like, which way are they going to ask it? So you teach it all these different ways. And then they ask it the other way. It's tough. It's tough. And I do think that they understand dilate means multiply. I think they understand that.
Yeah, because there's other teaks about dilation. Like there's not supporting a readiness teak about dilations. Since that isn't one of our bottom 5, I'm assuming they did pretty good on the other parts. So.
Yeah, and when we do review for STAR, it's like this is supporting.
Yes.
Yeah, we're like readiness, and then every day's readiness, right? And so right there, the 2 weeks before STAR, like supporting, I'm not worried about it, right? But yeah, you're right. Like if I do even get, a select few kids to practice some of the supporting centers, and that could mean some big.
And something the admin team has been talking about is the last couple of years, y'all have been very consistent with those 8th grade math scores in having a high percentage of approaching, but we'd like to see the meets and masters continue to go up. And so looking at these supporting standards that were low, these might be some of those things we target with your INOVA kids, that you color as the green and the blue.
Yeah.
Because they're the ones who we can target with this. Maybe not our kids that we're just celebrating that they passed or met growth in any kind of way, but what can we do to give our meets and masters kids more skills so that we get more kids in that range? I think there was about 12 kids that were shy of meets by 1 or 2 questions.
Yeah.
So we're really, really close to increasing that percentage. And I know it's hard with the top half of the 8th graders taking Algebra 1 instead of 8th grade, but we also need to look at preparing them for Algebra 1, because another thing we talked about in the board meeting last week was, and I was actually at this board meeting, I'm not making myself, was looking at your 8th grade math data that does not include the kids in Algebra 1 and comparing it to high school Algebra 1 scores. So tracking that same cohort of kids, they're really, really successful in y'all's 8th grade math classes, and then have a sharp drop once they get into Algebra 1. And it's kind of confusing when you're tracking those same kids,
Yeah.
because so many of the Algebra 1 teaks show up in 8th grade. Pretty much that first semester is an overlap. And so the question that we're starting to ask is, one, is the vertical alignment piece there? So the 8th grade TEKS that directly relate to those Algebra 1 TEKS, are we supporting them for longevity, not just passing our 8th grade math star? How can we better support them to be successful on the Algebra 1 EOC their freshman year? And so if a lot of it is tricks or anything like that they're forgetting, we need to look at what can we do to communicate better between the two campuses.
That's what I was fixing to say. It'd be good to sit down with, you know, the algebra teachers here and figure out, like, how are you teaching this? And how am I teaching this? And which one are we gonna do together? Instead of me teaching one way and you teaching one way. Like,
And which way is showing more success with the kids?
Right.
You know, you've
Right.
mentioned your scoreboard and stuff like
Right.
that. I don't know if that's something that the Algebra 1 teachers at the high school are familiar with. So I think it would be really cool if we could coordinate some time,
Yeah.
maybe during that first professional development day in, I think it's September, if we could do some kind of vertical alignment meeting between 8th grade math and Algebra 1
Yeah.
to try to boost.
That'd be
I
great,
know
yeah.
we're not at the high school, but to try to boost those scores as well, because, you know, they're all our kids.
Yeah.
So, I know that doesn't tie into the TEK we were just talking about, but it just kind of organically came up there. So, a couple other TEKs I want us to look at the questions for are both related to proportional versus non-proportional, and then representing proportional situations. So 8.5H, if you want to find a question on that for us, Michael, it looks like number 12, but we'll have to go to a different, yes.
So is it algebraic relationships?
I believe so, yes. So on 8.5H, we are at 15.82%. And this is just determining, is it proportional or non-proportional? So looking at our kids' breakdowns, this was the only question on this. So again, I know we're only looking at those singles and questions, which is hard, and we're not trying to focus on those negatives. Y'all just have so much to celebrate. And remember, we're looking at ways to improve, not nitpicking or focusing on those negatives. We just want to support these students better. So the majority of our students picked H. Over 58% chose H or C, as it's represented up there.
Well, if you look at just the first two, 1 4.25, 3 12.75, that part is proportional. But the next one where it's 5 22.25, then that's where it's not proportional. So if they only look at those first two, they go, oh, 1 times 4.25 is 4.25, and 3 times 4.25 is 12.75. It's proportional. They just maybe they check the whole table, they check the first two, and go, oh, these work, that's what I'm going to pick.
That is anything, that's what it is.
So do you always teach them just check the first two? Or do
Well-
you say pick any two,
Well,
first
here's
and last?
the thing for slope and y-intercept, all you gotta do is look at the first two,
Okay.
right? For this, you need to check all of them. So it's like seldom, frequently in class, I'll get asked like, do I need to look at the first 2 points or do I need to look at all the points? I'm like, if in doubt, look at them all. It won't hurt to look at them all, right? So,
There's not a time limit on this one, so.
right. So I think that's probably right too, but then again, you have tables and you have word problems too. And this goes back to I think that, I need to make warm-ups with multiple representations. Like, okay, there's the table, but how do you write that table down as a word problem?
Something interesting to note though is the 7th grade TEK that correlates to this one and leads into it, because they also have TEKs focusing on proportional relationship. They scored in about the 70% range of kids being successful on their proportional relationship question. So it seems like there's something lost between 7th and 8th grade. So that might be another vertical alignment piece.
Yeah.
How are they teaching proportional relationships? Because that is a main focus in 7th grade math.
Because I feel like in 7th grade math, the majority of it is proportionality in some form or another. Where 8th grade, it's one supporting standard. It's we don't really focus it on it as hard. So in 7th grade, when everything is proportionality, I feel like that for us, it's not a big thing, so we don't spend a lot of time on it. It's like we said, like, oh, it's gonna be like a question, and like for the most part we talk about, like, oh, I'm assuming most of them just chose the first two, checked it, good to go. That's one I'm going with. Is it being a supporting standard? I'm assuming that's one.
And if y'all are the experts here, if y'all say it's not something it's worth wasting our time on because it's gonna confuse them later on, you know, we focused in professional development last year on what do they need to know, what versus what is nice to know. If this is one of those what's nice to know standards, that's fine. But we just wanted to focus on, you know, where might we be losing them.
I think it's that we focus so much from tables, like be able to write those algebraic equations, y equals mx plus b, that like sometimes you're trying to do proportionality, and they confuse it, and I'd rather than make sure we get all those other ones right, try to mess them up by getting everything right. Do you agree?
Yeah, I mean, I think being able to show them, you know, show them how to do it with a pencil, show them how to do it with a calculator. Like, how many people chose something other than C?
About 59%.
Golly, well, this is tough. This is
Or
tough.
something other than, something
the right
other than
answer
C.
was only 16%.
Yes.
F was
58% chose C, and then between G and J, they were pretty equal. So we're running close to the end of our meeting time, so I want to close it out by focusing on some positives, since I know it's hard when we look at some of the things that could be taken as negative. So I'm going to steal your computer real quick, just because you have the data. Technology took mine to do an update, so I don't have it with me. Some things I want to celebrate. We've been talking about readiness versus supporting, and the purpose of this meeting was to look at those supporting standards because y'all are such rock stars at the readiness, so I want to call attention to that. So when we're looking at readiness standard questions, okay? TEAK 8.4b, 74%. That's a readiness standard. We had 80% on an inline choice. Get another readiness standard correct. Let me put this up there so that you can all see what I'm talking about. Alright, number 3, another readiness standard, 94% of your students getting this question about identifying functions, right? And I know y'all spend a lot of time on that. 8.4c, another readiness standard, we're at 86.44% on that question right there about using a table to find slope. Okay, so there are so many things to celebrate. Now this is by question breakdown. If we look at the learning standard breakdown, with these readiness standards versus supporting standards, they all come up red, just ignore that, okay? But look at 8.4c, using data to determine the rate of change or slope. Okay, that is something that 7th grade math struggled with. They were only about 35% accurate on that correlating TEAK, and y'all got them up to 75%. That's twice as what they were showing.
That's gonna be huge in Algebra 1.
That is huge in Algebra 1. 8.5G, another readiness standard that we were at 76%, that identifying functions. 8.5I, another readiness standard, writing an equation to model y equals mx plus b.
Multiple representations.
Yes. So there are so many questions to celebrate. Even these ones in the 60 range in those readiness standards is huge. 8.10c, another readiness standard, explain the effect of translations over the XY axis for reflections and rotations. That's huge. So more to celebrate than to look at. So the last thing that we're gonna look at real quick here is the reporting category breakdown, because I know this isn't necessarily a data statistic that we look at very often. At least I'm not sure that we do. Have you ever looked at this breakdown? Did you know it existed?
I knew it existed, but like, I got more interested in the exact TEAKs rather than grouping the TEAKs as a reporting category.
Okay.
So I know, me personally, I never looked at this.
So the only reason I wanted to call it to your attention is because on this 8th grade test, the majority of those questions are coming from reporting categories 2 and 3. And so that's awesome because 2 is obviously our highest reporting category, but 3 is our lowest. So that might be something as we're planning this year and as y'all are in your department meetings talking about your calendar and adjustments that you're gonna make, looking at those TEKs in reporting category 3 and just seeing how we can strengthen them this year. But overall, amazing data. So you can see right here, we've got that approaches at 89%.
That's what taking out the
That's
top.
taking out the top third of our students. That is unheard of, and a lot of that was you, Coach Levins. Meet, we're at 58%. You know, the district's goal is typically 90-60-30 model, so we're right there on track for getting the meets percentage up. The masters is the hardest one because that top third of percentage of the 8th graders are in Algebra 1. So being intentional about looking at those supporting standards, because those are the ones that are gonna get your bubble kids from meet to masters over the hump. And so I know a lot of the times we focus on our lower kids or the kids that need the most intervention, but we also have to remember that our TI works both ways, and we want to intervene with those kids that need the push to excel further than they have in the past. So, because those are the kids that kind of get forgotten because you know they're going to be successful. So what can we do this year to be intentional about it, supporting those meets kids to get to masters? And you don't have to have an answer, it's just something to think about.
Yeah.
But that was what I would like y'all's goal to kind of be for the year, is just the intentionality piece with trying to get more kids to that master's level. I'm not saying double it, get to 30%, that if you did, that'd be awesome, but even if we could just get a couple more kids past that finish
just
line.
being intentional about it, right?
Yes. Because
Let's
we
put some
harp
effort
on
into it.
being intentional about targeting those kids that were at risk of failing. We don't really look at the high end,
Right.
especially in
Yeah,
these classes
yeah.
where you might not have as many of those kids. So identifying the ones that have the potential and setting those goals with those students.
Yeah. That's smart. I'm guilty of that too. It's like, you got so many kids who didn't pass last year, it's like, you gotta help them, but yeah, you're right, you gotta help everybody, so.
Anybody have any final thoughts before we close out our meeting?
I like knowing where we're doing great and where we need to like, alright, how can we make this better? We're doing great, let's make it even better.
I like being
never
told
wanna
that,
be-
right? I like being told that. Like, it's
Yeah.
kind of uncomfortable, but I like it, cause it's
Yeah.
like, okay, now I have something.
I know, yeah.
You know, it's like we've talked about at Capturing Kids Hearts Training, right? And we talk about those social contracts with our students and holding them accountable and teaching them, you know, if they're not applying that social contract, doing the thing, right? And that was our big push last year. And so applying that to ourselves. We want to be held accountable in the same exact way, and our goal is to help and support all students. And so we have to think about
Yeah.
where are they missing and where might we have those shortcomings.
Yeah.
So I think that's it for today. Our next kind of department meeting will be next Tuesday. So if you want to think about ways you can intentionally support those masters kids or getting more kids to masters, come with some ideas. Okay.
Awesome.
Any final thoughts?